Hey Calculus, welcome back. Our objective today is going to be to convert from integral to limit notation. This is a type of problem you'll see typically on a multiple choice question on the AP exam. I've got the checklist on the screen. You know what to do from here. Force pause on your screen. I'd like for you to just copy the graph that I have. I'll try to make it small so that it fits in the screen. But go ahead and just copy the graph and then hit continue when you're ready to continue. All right, so what we've got here is just some generic graph. I'm going to call it, y equals f of x. And I've created 4 rectangles. And what kind of approximation method am I using here? I'm using RRAM, okay? And so in this case, what is n? Do you remember? N is the number of rectangles, so in our case, n is 4. And then delta x, delta is the Greek letter we often use in math for change. So delta x, we're going to assume is all equal bases here. So that's just your change in x, okay? So let's say if I were going from x equals 1 to x equals 5, and I had 4 rectangles, then each delta x, each base would be what? It'd be 1. And the way we get that, let's write this please, would be 5, or in our case b, minus 1, or in our case a, all over the number of rectangles, right? Which we generically use n. In this particular case, it's 4, okay? So what I'm going to do is I'm going to write the equation for each little area, and I'm going to add them up using sigma notation, okay? So this first one here, remember, this is a base, this is delta x, right? So would you agree that this x value right here is a plus delta x? Okay, so that means that this y value, that y value there, would be f of a plus delta x, right? And so my area is going to be this y value, this height, times delta x. So my area is going to be f of a plus delta x, that's the height, times my base, which is delta x, okay? All right, let's keep going with that little formula here, so that pattern. So here's another delta x, right? So do you agree that this x value is a plus 2 delta x, right? So that means that this y value here is f of a plus 2 delta x. Okay, so the area of that second rectangle is going to be the height, which is the y value, f of a plus 2 delta x, times the base, which is delta x. Okay, are we seeing a pattern? Let's see if we can keep going here. So here's another delta x, change in x. So now this x value is a plus how many delta x's? Plus 3. So the height is going to be f of a plus 3 delta x. So that will be the height there, right? And then the base is going to be still delta x. Okay? Last rectangle we've got here. So now this x value is b, also known as a plus 4 delta x, right? So the y value, the height of this rectangle, is f of a plus 4 delta x times delta x, okay? So each area looks really similar, right? Each one, the base is delta x, correct? So we can write that the base is always delta x. And the height is almost the same, right? The only difference is this little index here. So the first one is f of a plus 1 delta x. The next height is f of a plus 2 delta x, plus 3 delta x, and plus 4 delta x. So in general, the height is f of a plus something, I'm going to call it k, delta x, right? So that is my area, my height, or my y value, times my base, which is my change in x, okay? So if I want to sum this up, my area is going to be the sum And I'm going to start at k equals 1, right? And end at k equals 1. At k equals 4, which is also n in our case. Okay? And then I just want to sum up 4 of those, right? So going from 1, 2, 3, 4. So I'm going to just insert that f of a plus k delta x times delta x. So this would give me our RAM, okay? Now my goal is eventually to get to how many rectangles? To get to an infinite number of rectangles, right? So my goal is to take the limit as n goes to infinity, right, of this area here. Okay, so a lot of little notation, but this is where this formula comes from. Okay, so let's put that in our notes. Let's try to make sense of some of this. So what we're going to do is we're going to take the limit as the number of rectangles, which is n, runs all the way to infinity, okay? And we're going to sum up a whole bunch of these rectangles. So I'm going to start, I'm just using k as my index. We could have picked any letter other than n, I guess. So I'm going to start at k equals 1, right, my first rectangle. And then that last example I ended at 4, but I want to end at n. I want to keep going, right? Infinite number of rectangles. All right, now my rectangles, the formula is always height times base. The height that we just got was f of a plus k delta x, right? I have to move over delta x each time, and then times the base, delta x, okay? That is the kind of clunky, non-elegant notation. If we change this to integral notation, we get a much more elegant representation. So this is equal to the integral from x equals a to x equals b, your start and end, what we just did in that previous graph, of f of x, and instead of that delta x, we turn it into a dx, okay? Now, delta x, can you please write this, is equal to, remember, b minus a divided by n, so the length of your whole interval divided by how many rectangles you want. And then so when we're doing these, our first goal is going to be to identify a, b, f of x, and delta x. All right, let's try a couple examples. And force pause on your screen, can you please copy example 1 in your notes? Okay, so our first goal, remember, is to identify a, b, f of x, and then also delta x, all right? So for a, what do we have there? A is going to be 0 right here. Okay, what is b? B is 3. What is f of x? Right there, x squared, right? And then delta x, remember, is b minus a over n. So I would have 3 minus 0, which is 3 over n, okay? And that will be the width, the base of each rectangle. Okay, so let's go with our formula. Our formula goes limit as n approaches infinity. Pasted it up there for you. The sum of k equals 1 to n. It's always going to start that way, okay? And then we're going to have, let's go ahead and call this f still, f of a, which was 0, right? Plus k is just that index, so k times delta x, which is 3 over n. Close both sets of parentheses here, and then times delta x, which again was 3 over n. Okay, here's what I want to do first. Let's clean up just that part first, all right? So we are going to have the limit as n approaches infinity of the sum from my first rectangle to my last rectangle, f of, okay, now this part, let's clean that up. I don't need the 0 plus something isn't affecting it. Then k times 3 over n, another way, again, just to kind of clean it up, is going to be 3k over n. So that is that, and then I still have times 3 over n. Okay, we are almost done. So now I need f of 3k over n. Well, what was f of x? It was x squared. So I'm going to come anywhere I see an x, I'm plugging in 3k over n, right? All right, so final answer. Limit as n approaches infinity of the sum from k equals 1 to n. Now f of 3k over n will simply be 3k over n squared, right? And then I still have that times 3 over n. Okay, again, clunky, not the prettiest, but that is how to convert to limit notation. First, pause on your screen. Can you please copy example 2 and then also identify for me a, b, f of x, and delta x? Hit continue when you are ready to continue. All right, so here is what we have so far. Now we're going to plug into our formula. So our formula always starts with the limit as n approaches infinity. Again, that represents the fact that I want an infinite number of rectangles. And I want to sum up all the rectangles, starting from my first rectangle to my last rectangle. And then my formula, I need the height of each rectangle, so that's the y value, f of a plus, let's go ahead and plug in a. So f of a is 1, right, plus k delta x, and for delta x we got pi minus 1 over n, close both parentheses, then times delta x, which is pi minus 1 over n. Okay, now last time we cleaned this part up a bit. There's not a whole lot to clean up there. If you want to put the k in the numerator, you can. Still pretty clunky. So I'm just going to jump to our final answer. So now I just need to plug that input in anywhere I see an x for f of x, right? Because I want f of all that stuff. So it's going to be sine of all that stuff. Let's write that. So I've got limit as n approaches infinity, sum from k equals 1 to n of sine of all this stuff. So 1 plus k pi minus 1 over n, and then times, again, delta x, which is pi minus 1 over n. And that is my final answer. All right, force a pause on your screen. Can you try example 3 on your own? Hit continue when you are ready to check. I've got the answer on the screen. If this is not what you have, you can pause and correct anything you need to. All right, and force pause on your screen. Can you please copy this last example in your notes? So we're back. So now the idea is, can we go the other way around, okay? So we still need to identify a, b, and f of x. Now, answers can vary, but I think the most straightforward a would be to use 4 as a, right? So let's say a is 4, because it goes f of a plus k delta x, right? Now, take a look here. If delta x is 1 over n, what do you think b has to be? So b has to be 5, right? Because b minus a has to be that numerator 1, okay? So I'm just going to add that number to a to get my b value, all right? And then the last thing is, what is f of x? Well, this is a plus k delta x, right? And then if I put this on there, that's supposed to be f of all of that. So f of x must be, if you replace the stuff I circled with x, f of x should be x squared. So my answer is integral from 4 to 5 of f of x dx. A lot prettier, right? Okay, now one thing I have seen on the AP exam is, okay, what if that were not an option on your multiple choice? So what if you had to make a be 0? Okay, so a has to be 0, okay? Well, now b has to be what? B has to be 1, right? Because that numerator is the difference between a and b. So I'm still just going to take that numerator and add it to a to get b. Now here's where we have to do a little bit of thinking. So f of x, in this case, I've not taken care of that for, right? So f of x is going to be, let's write it here, quantity 4 plus x squared, right? Because now my x I would only plug in here. So my final answer would be integral from 0 to 1 of 4 plus x quantity squared dx. Okay, let's take a look at this graphically, make sure you're convinced. What does adding 4 to the inside of the parent function x squared do? It's going to shift to the left 4, and notice that my limits of integration have shifted to the left 4 as well. Okay, so the very first integral we got was f of x was just good old x squared, and we shaded the area from x equals 4 to x equals 5, right? Then we said, well, that's actually equivalent to, it's equivalent to a lot of areas, right? But the one we wrote was going from 0 to 1 of f of x equals 4 plus x quantity squared, okay? So you can see there are multiple representations. Again, my eyes would not have naturally done a 0 as my a value, but just you know they can pop up different ways on multiple choice. So in your assignment, I'll ask you to write them both ways. All right, you all, that is all I have for this lesson. I will see you next time.